Okay, so the recording is started and we'll put this on our YouTube channel later. Ivan is our speaker for today. And Ivan, do you want to introduce yourself a little bit?
Yeah. Actually, I have an introduction slide about me. So first, I would like to say that I'm very glad to make a presentation for this wonderful society. Thank you very much for inviting me. So from my side, I'm going to do my best to make this presentation as insightful and interesting as possible. Just a few words about me. I've been into data science and machine learning for more than 10 years, mainly in retail banking and finance, with applications in customer base management, customer value management, and CRM. Those things typically are used as the same subject. Currently, I work as head of data analytics and data science in a brokerage company here in Cyprus. For me, it's here. For you, it's there. It's there, of course. So that's there are my contact details, and you will have them further on the final slide, of course. And if you have any questions, even after the presentation, you can get in touch with me via LinkedIn, email, or Telegram. So just that's, I think, quite short introduction. But anyway, I can say some more things if you want. But do I need to say some other things? Maybe no. Yeah.
Everything's good for the moment. Yeah, and then we'll have a bit of a Q&A at the end. Ivan, what's your preference? Do you like people to ask questions during the talk, or do you prefer to wait to the end?
Whatever you want. Actually, for me, right now during the presentation mode, I cannot see the questions in the chat. So I think it's going to be quite hard to answer them because I cannot see them while showing my presentation. So maybe
yeah, I mean, I'm happy to. Yeah, I'm very happy to read out some of the questions in the chat. Yeah, so I guess we'll leave some time at the end for Q&A, but also if anyone has any questions in the meantime, then you can put them in the chat and I'll read them.
Yeah, great. Then when questions happen, so I just can answer them at the time when they happen. So when they asked, so that's absolutely okay, I think. So you just say, okay, there is a question, and then I answer the question. And anyway, in the final part of my presentation, we can also speak about some more things and discuss, related to my presentation, different questions and what you want to know else about the subjects that I'm going to speak about today. So, okay. So let's start, I think, yes. So it's time to go through the topics. First, also, I would like to say the following thing, that the longer one works in some specific area, the more often he or she asks the question, why am I doing that? So for me, it happened several years ago, and I started to want to understand the big picture and how it really works and why I create those solutions based on machine learning. So, but then I realized that it's even better when you just start your journey, your career path. It's always very good to understand clearly why exactly and for which reasons you solve those tasks. So I decided to make my today's presentation more business oriented so that we understand why we need those solutions and how they are applied to real life business tasks. But anyway, we're going to have some technical details and aspects. And even if you want to go deeper, we can go deeper and discuss some more technical details if you want. So also, I have already introduced myself, and then just short outline of my presentation. First, I want to explain what CBM means, customer base management, which tasks we solve in customer base management departments and in large companies. Then I would like to speak about a specific task from idea to final solution and its the measurement of its effect on the business. If we have enough time, also I would like to speak about deploy of a solution in a typical customer base management IT framework. And then, of course, as I said, we can have questions and answers session. So let's start. So what is customer base management? Actually, let's have an example. Suppose we have a company, and typically in big companies, specifically working with retail business, we have a lot of customers. Yes, so a company with big number of clients. And there are different types of clients, actually. There are clients like this one, so frauders, clients with low profitability, high operational costs. And actually, those clients are typically not desired to be within the company. And there are clients like this one, so loyal, very highly profitable, those who have low operational costs and who generate a lot of income for our big company. I don't mean that our company is in Gotham City, but anyway. So in customer base management, actually, we try to extract as much value from those profitable clients and try to get rid of those non-profitable clients. So we apply a number of different tools so that we maximize our customer base value, because actually for any business, the value of a business is the value of its customer base. We have millions of clients, and those clients, have different value, and they generate income for our business. So, as I said, just one visual before, CBM is about extracting maximum value from existing customer base. And which tools do we use for customer base management? First, of course, cross sales. If you, for example, have a credit card, maybe you need a mortgage. If you have a mortgage, maybe you need a cash loan to finance your flat renovation. So it's called cross sales. And when we have a lot of clients, we try to figure out which clients maybe offered some extra products which our company can provide to them. The next instrument of customer base management is product customization. The most simple example is individual pricing. Sometimes we can change prices on an individual level. For example, if you have a credit card or a cash loan, we can customize your interest rates based on your characteristics. And so some clients get, fortunately, lower interest rates. Some clients get high interest rates, unfortunately. But anyway, we can do the customization and understand which pricing is better for each individual client. And the last but not the least instrument of customer base management is, I call it, keeping involved. So we want our clients to be involved in the usage of our products. Yes, for example, I guess many of you have, or some of you have a Revolut account, and sometimes you get notifications like, okay, that specific stock in your portfolio has just grown by 5% within the last 2 hours. Yes, and so you just think, wow, I have a great stock, maybe I need some actions, and you maybe buy extra stocks, or maybe you sell because it's time to sell, I don't know. But typically large companies with millions of clients, they try to keep their clients involved by sending notifications, reminders, good news, giving news about new features, and so on and so on. And actually the power of communication actually is very, very strong. So these are the 3 key instruments of customer base management: cross sales, product customization, and keeping clients involved. And by using of these tools, we maximize our customer base value. So let's go to the following thing. What if we have just a few clients? I think that the management of a few clients in our company is quite simple. We can hire several managers who can customize products on an individual level, who can make a cross-sales process, who can notify our clients about interesting and new things, and so on and so on. But what happens when we have thousands or even millions of clients? Of course, when it's a big numbers game, we cannot hire individual manager for each client, and this is where we start to need some extra tools, maybe some technical tools that help us with the customization, with individual contact policy and things like that. So that's why actually machine learning is so widespread in customer base management. We, with the help of those smart algorithms, we can understand actually, or machines can understand what to do with clients on an individual level, because it's impossible for a human to understand the behavior of 1 million of individual clients. So which tasks we can solve by machine learning applications in the framework of customer base management? The first type of tasks is very simple. It's called product propensity modeling. We typically try to understand for which products are good for our clients and which products we can offer, which extra products. So as I said before, if a client has a credit card, he may need a mortgage, and so on and so on. And this is not only about proposing extra products. It's also about not only products, but the right time of proposal. So we need to understand the right customer journey when he or she needs the product right now or maybe later. And so product propensity modeling is about understanding the right moment and the need of a client. Also, with the help of those smart algorithms, we try to predict different customer behavior. So, for example, if we know beforehand that some clients are going to leave our company, we call it churn or churn prediction. We can understand that, okay, those clients are going to leave us, maybe for competitors, maybe for other reasons, and why not to try to take some actions to stop them from leaving, because our clients are the ones why we exist, why we generate income in our business. So there are a lot of different tasks about predicting customer behavior. One more very important and famous, I think, task is called lifetime value modeling. When we try to predict the future value of each client. It's a very important task, and it has multiple applications in many businesses, not only in banking, not only in telecom, but in some retail, in some smaller retail businesses, because it's always about future incomes that we can get from each individual client. Yes, and so it may be quite a simple task or maybe quite a hard. For example, in banking, lifetime value modeling is very hard to model thing, because we have multiple different products in banking, very, very different from each other, and it's quite hard to understand future value of consuming those products. But anyway, this task is solvable. Also, I think one more very important group of tasks that we solve in customer-based management with the help of machine learning algorithms is called product customization. As I said before, we got to understand for each individual client which parameters of a product we can fit to the needs of that client. And so today's example, which I'm going to speak about in a couple of minutes, is about product customization, by the way. And also we have some other tasks, but I think that these main types represent are the best representation of what we do, applying machine learning algorithms in customer base management. So I hope now it's quite clear which tasks we solve. If you have any questions, I can answer them. There are no, I guess, because I hear only silence. So now I would like to share with you a real life task, an example. It comes from my actual experience. That's the solution that I created myself working for some large bank with millions of active clients. So it really had a real business impact on the business of the bank. And so I want to share with you everything starting from the idea till the final application and measurement of its business value. So real life example, it is called customized credit limits. So the setup of the task, it's a bank and millions of clients, and hundreds of thousands of them are credit card holders. So there are a lot of clients who have their credit cards, and of course each client shows some individual behavior. For each credit card, there is a very important parameter, which is called credit card limit. It's the maximum amount of debt that a client can have according to his credit card. So he make purchases, but he cannot exceed, for example, $1,000 or $6,000 or $500. It depends on each client. So each client has an individual credit card limit. Of course, some clients have high utilization of credit card limit, something like 90% of the maximum amount of debt. Some clients are afraid to use too much money, and they are like 15% or 30% of their maximum debt that they can have. But anyway, every client has a different type of behavior according to his product usage. Of course, for the bank, it is always better when clients have more debt. So the more debt, the better, because debt, I mean, credit card debt is an income generator for a bank. And by the way, for credit cards, we typically have very high interest rates. And so credit card portfolio, we call it, is a very good income generator. And in customer base management teams, people always think how they can extract more value from the portfolio, how to increase the amount of debt, how to increase the amount of debt per each client. And so it's a very important task, actually. So the task we want to solve right here and right now is the following: to answer the question, can we persuade our clients to spend more than they spend right now? So that's the setup. So, and we come up with the following hypothesis. So what if there are some clients who would feel more comfortable to spend more than they do right now if they had more credit money available? So as I said before, every client has a credit card limit, and some clients, they don't use as much money as they can. Maybe they are afraid, or maybe they think, okay, I can afford to use only 30% of the maximum value that my maximum amount that my credit card allows me. But anyway, here is a hypothesis. So we just think, okay, what if we give some extra credit card limits to some clients? Maybe they start spending more. And of course, we understand that there might be some clients who instead would react negatively to a bigger credit limit. Of course, it might happen. And for the simplicity of this task, I would assume that we already increased credit card limits by business rules before. We can consider those increments which we did before. We can consider them to be random. It's just for the simplicity. I just want to make it as clear as possible, because if we just speak about experiments, we will go into too deep details. But anyway, so the task here that we want to say is to test the hypothesis whether we can provide some clients with extra credit card limits and gain more debt that our customers have, and so that we can generate income, extra income, and make more money. So that's the task we would like to say. If we consider it in the mathematical way, we actually want to build a function which predicts delta credit card debt conditional on delta credit card limit and x. Here x is the feature parameter for each individual client. It includes age, it includes country of residence, it includes debt to income ratio, and many, many other parameters. And so it's a function that we want to try to model. And once we have this function, we can understand on each individual client level how much we can increase delta, how much we can increase credit limit, and how much delta credit card debt we get. So the whole task in the mathematical way looks like this. So we just want to build that function. And so the machine learning algorithms can help us with that thing. Okay. So to solve this task, of course, first we would like to gather and prepare our data for modeling. From my experience, it's by the way, we have a question. Okay, not now. From my experience, it takes around 80 or maybe even 90% of time to gather the data, and maybe 10% or 5% of time, I mean working time, to build actually a model. Finally, when we make our data preparation, we would like to get something like table that we see on this visual. So for each client ID, from the past for whom we made credit limit increments, we would like to see our target variable or target feature, which is called delta debt. Yes, we had for example, the first client, this amount of delta debt as a result of this amount of delta limit. And also there is X feature vector, which represents each client and his or her type of behavior and maybe some demographic features and so on. Typically, when we work in customer-based management, we have here you see the picture 360-degree client analytics data mart, which typically is built by our team of smart data engineers. Actually, data engineers, I think, are the best friends of data scientists. And so finally, as a result of our data preparation process, we can get a table like this. So for each client, as I said, we have the target value and the features value, which we want to try to use to predict the target. There are many, just a moment. Yeah, there are many aspects of data preparation, but I would like to speak about the most important principle that we have to take into account while preparing data for training our model. Just suppose the following example. We have Batman, yes, and we train our model on Batman. But then when it comes to predicting client behavior, we have Joker. And just imagine what happens if we train our model on Batman behavior and then try to predict the behavior of Joker. I guess it's going to be a problem. So the main and I think the most important principle of preparing data for training any model is to make sure that the training data set is as close as possible to the execution data set, the one where we try to predict something and to apply our predictions in business. So when we build the model, we have to make sure that, okay, we trained on Batman, on the mixture of Batman and Joker, so that when we apply the model, it can predict both Batman behavior and Joker behavior. If we go back to our example with credit card limits, actually, it has the following illustration. Typically, when we carry out experiments, those random experiments with delta credit card limits, we have only clients who actually had credit card delta limit. Maybe somebody got $100, somebody got 1,000, and so on and so on. But when we train our model, we've got to include in our training data set those clients who didn't get any delta credit card limit. So we force the inclusion of those clients in our training data set. So we must include those who don't have credit card limit, or I mean zero delta credit card limit. Yes, so that the model understands how to predict delta debt in the future for each client, even for those who don't have any limit increment. So that's how this principle applies to our specific case with credit cards. So now just a few words about building a model. I think that right now in 2023, building machine learning models has become so easy that I just don't need to speak too much about it. You know, you can Google it. I mean, the first Google search page can give you the right Python code, how to train like GBM or CutBoost or XGBoost, the whole code. But anyway, there are some key steps. So first we have our training data set. We split the data into several subsets like training, validation, testing data set. Then we, of course, do the cross-validation, I mean, k-fold cross-validation to find the right hyperparameters for our algorithm, for example, for our XGBoost or our gradient boosting, and then we find the right hyperparameters. Then we pick the best model. I mean that we can try neural networks, we can try gradient boosting, we can try some linear models, and then we select among of them the best one. Typically in tasks like I just explained, gradient boosting beats everything, even neural networks, which are so popular today. But I think that when we speak about tabular data, again, just gradient boosting is a very strong and good algorithm. But anyway, it's quite simple procedure, I think. Just it's not too hard. So we just imagine that we just did all the steps, and then we have our model. I mean, we have the now we have the formula that is shown on this visual. So for each individual client with feature vector X, his age, his debt to income ratio, his other products consumption, and for each level of credit limit, we have the function which can predict delta debt for that client. And if we speak about our specific task, it's a challenge to understand the right delta credit card limit, so that the one which maximizes delta debt. It's a tricky task because this function typically fit by those black box algorithms like neural nets or gradient boosting. They don't have a formula, yes, so they are like black box. Of course, for example, if we speak about gradient boosting, it's a very hard combination of decision trees which are combined with some weights, but there are typically hundreds of those decision trees, and you actually cannot write a formula which you can just find the optimum value of. And so in this specific task, actually, we can do something like brute force grid search. For each client, we set different amounts of delta credit card limit, and then we calculate several times this function for each client and find the one delta credit card limit which maximizes the prediction of delta debt. And as a result of this procedure, we have a table where for each client we have the optimal delta limit and the optimal predicted delta debt. Yes, so for example, some clients actually here in this example have zero delta limit because the increment of their credit card limit may cause some loss of their debt. So it's better not to touch those people, just let them have the credit card limits that they used to have. But those green clients, actually, they are predicted to have that increment as a result of credit card limit increment. Okay, so we have such predictions, then we just launch a campaign. We notify our clients about having extra credit card limits. And also, of course, in our product systems, we set new credit card limits for them. Of course, each client typically may refuse credit card limits. It happens quite rarely, by the way. And then we've got to understand what happens to them. And by the way, while I was speaking about all those technical things, you may have said, whoa, how do you understand that this model actually is a good one? Didn't you forget about any metrics? Yes, and of course there are metrics like root mean squared error, R squared, and some other metrics that we use in tasks like this, I mean regression models. And of course, while fitting the model, we use all those metrics. Yes, of course, we use them. But these things are very poorly understood by those business managers who run the business. So now I want, in addition to things like root mean squared error, provide you with the right procedure how to measure the effect of our model on business in this specific case. And this looks like this. So just before we first, as I said, we have for each client the most optimal delta credit card limit, and then we want to launch a campaign about notifying clients and also about increasing their credit card limits. And so we divide our clients into three main groups. The first group actually is the group of clients who, despite the fact that they have some optimal predicted delta credit card limit, we set for them zero limit increase. So it's our baseline group of clients, which will show whether increment of credit card limit generally works. The second, I mean the yellow group, are the clients who get a random limit increase. It's the second baseline group. So, and the last, and I think the largest group, is our test group, for which we set the limit increments that we predicted by our model. And of course, we hope that the test group gets better results than the random limit increase, because if the random group with random limit increments beats our group with which was set by the model, I've got good news. I mean, yeah, because random has to have lower predicting power than our smart model. And so in each group, of course, we measure average debt per client, and we see which type of uplift we can get. One more very important thing, very important thing, which has to be taken care of course, is that all the three groups has to be randomly selected. So because so that we can compare them to each other. So one very simple test for understanding whether, just for high level understanding whether everything is okay with random selection, is that at the point of time 0, all of them have the same average amount of debt per client. And so then we can look at each individual group and see whether our test group with smart predictions by the model demonstrates better results than the random group, and of course better than the zero limit increase group in terms of their debt goals. So that's, I think, is the best way to measure the value, the business value of what we create. Of course, those, as I said, those smart metrics, which go from statistics, from machine learning, they are important. But when it comes to real business decision making, everyone wants to understand how much value, actually, how much money we can get from each solution. And this approach actually allows us to see that real value in terms of uplift from zero limit increase to random, and from random to our smart machine learning model. So I think that that's all I wanted to say in terms of this specific example. So how we created it was an idea to increase by some smart rules credit card limits, and to get from it as much debt increment as possible. And actually it was a success story, because we managed to implement the model and it showed very good results, and then it started to work and bring a lot of money to the bank. Okay, I guess we
a quick question just with the last example. So do you apply then at this stage any kind of significance testing just to confirm?
Oh, yes, of course, we can speak about it a lot. Of course, when we measure the uplifts, it's an essential part to understand that we have to see that uplifts are significantly, I mean, at some confidence level, like 95%, are significantly high enough, significantly different from zero. Of course, it's always about mathematical testing. Yes, so just this is quite a simple task, so we can use some T-student test to understand that actually it's not that hard actually. So just we have numbers of clients in each group. We have average debt. We can calculate expected mathematical values, expected sigmas, and then just apply students' formula. So student t-test in that case. Yeah, of course. Thank you very much for this question. Yes, whenever or whatever task we solve, we always apply statistical testing. Moreover, it's a challenge to pick the right group 1 and group 2 sizes so that we can understand the real value, because those group sizes, they actually may influence the significance level that we can see, you understand, because the numbers of clients in each group do influence the testing. Yes, so the formula for T-student, for example. So yeah, of course we do that.
Yeah, that makes sense. Thank you.
Yeah. Any other questions?
Yeah, there aren't any questions in the chat so far, so I think.
Okay, let's go further. Actually, I didn't expect to. I just thought that it was all the time, but I think we have some extra time till 8 o'clock, right? So there is one.
I think maybe 10 to 10 to 8 or so, just to leave another 10 minutes for questions.
Oh, yes, of course. So we have 10 more minutes. And I have one section that I just didn't know whether I would be able to have enough time for it. But I just explained a real life example, how we solve it. But also, I think it's a very important thing to speak about, the deployment. So we have our machine learning model, and the deploy part is a very important thing too. And so let's speak about deploy in terms of CBM IT framework, of course. And the first thing I want to explain is the general high-level IT framework of customer base management, just so that we understand how we deploy machine learning models there. And so actually, CBM IT framework is mainly about the right data flows. So in each company, for example, again, it's a bank. I used to work in banks, so I know so much about them. But in each large company, we have different systems. For example, CRM system, different product system. Yes, credit card transactions live in something like Way4 or profile system or some other types of systems. Yes, cash loans and mortgages, they live in other product systems. And typically in a bank, we may have something like 100 different systems. And in each system, our clients generate a lot of data about their behavior. So they contact with the company, and we see data about those contacts in CRM system. Yes, so they just make their transactions using their credit cards or debit cards. We see those transactions in the data in product systems, and so on and so on. So our clients, they first generate a lot of data. And we, in customer base management, of course, create ETL processes to get all those data and to gather those data in one place, which is called analytics data warehouse, or just data warehouse. In the data warehouse, of course, we create different data marts. There are a lot of interesting technical things, which I also can discuss if you want. But here in analytics data warehouse, we build all the marts and we unite all the data about our client's behavior. And of course, you see here on the picture some sort of feedback loop to the systems. Yes, why we have this arrow? Because, for example, making decisions about individual clients. Yes, setting just like in our case that we have considered today, we set individual credit card limits. And of course, when we decide on individual client level, which client needs extra money, we have to set those extra limits back in the product systems, of course. Using our data warehouse, we build mathematical models, we do our research, we make our decisions about our clients. And then in customer base management, we have campaigning system, which connects typically our data warehouse and our decision-making with communication channels from which we try to reach our clients. It's like, so in campaigning system, we form campaigns and we load our communications to push notifications, to emails, to calls, and then our clients get communications, change their behavior, and then we see again that change in the systems, and then we extract data by ETLs, and again see the changes in our data warehouse marks, and then we adapt, and so on and so on. So it's like an infinite loop which goes and goes and goes, and we do our research. So when we want to apply machine learning models to deploy actually in this framework, there are three main options. The first option, yes, as you have seen today, we make predictions on individual client level. Yes, so for example, for each client, we find the best delta credit card limit. Then we have to communicate with those clients, and then we have to load those predictions, those delta credit card limits into our product systems. And so the first approach is to run directly our model in data warehouse. So we got the formula, and so we can try to run it directly in data warehouse. For example, we have something like Hadoop or Teradata or some other solutions, maybe Oracle. But unfortunately, not all the types of data warehouses allow to run machine learning models. When it's a simple model, something like linear model, we can hard code it with SQL language and run it on data warehouse, but it's quite a rare thing. So this option is not always available for us. But anyway, it may exist, and I had such experience because we didn't have something like the options that I want to discuss a little bit later. But we can actually run our models directly in data warehouse, especially if we are able to hard code those formulas, specifically in the case of linear models. The next option is to run our model somewhere else, and then to load predictions to the data warehouse. And then from the data warehouse, again, we go to the product systems and we go to the companion system and do all that we want. Yes, for example, we trained our model on our machines, on our computers, and then we run the model there, and then we load predictions to the data warehouse. This approach may not be a good one because sometimes the capacity, I mean, calculation capacity of your machine may not be as high enough to run the model for all millions of clients that we have in our company. But sometimes when we don't have other solutions, we do that. And I think that the third option is the best one when we have a separate so-called model execution framework to which we deploy our model and which is integrated with both data warehouse and products systems. Yes. And then we run our model in that model execution framework. Yes, it's a production system, and which has to be sustained and has to be supported by engineers. It's like a whole IT solution in the whole company, but it does solve many issues with models, their predictions, and their deployment into the systems. But typically, to have such solution, we've got to have a good IT team. Yes, that's the third, and I think the best type of solution that we can have in our application. Yes, when we want to deploy a model. So in our example, when we created a model, we have these three options. We can, run the model, if it's a simple one, directly in the data warehouse, have the predictions, and load them into all the systems we need. We can run the model on some separate machine and then load the predictions directly to the data warehouse and do all we want. And of course, we can, if we have, use model execution framework where we can deploy our Python models. So that's all about the deployment. Okay. So what I want to say, the last but not the least, oh, I didn't separate the slide, but then, okay. So I want to say that all the steps that we've come through today are just the journey's beginning. Typically, when we create a model, it's just the first step, because then we go to the model life cycle. Yes, so today we collected data, we built our model, checked model quality, we deployed our model. Of course, we monitor performance, see what happens to our predictions, whether they good or they are not. And then there is a feedback loop when we go back again, collect extra data, because with time, everything may change. And we, again, recollect data, rebuild our model, check the quality, and do the things again and again. It's like infinite loop. But I think that there is one more important thing in that loop. It's the left-sided arrow. So sometimes we've got not just to recollect data and to rebuild our model infinitely. It's always a good idea to challenge the initial business hypothesis, because sometimes even good things that work may be even better if we go one step back and analyze whether the whole business task framework is right or wrong. Yes, so just I think that the most important part in any technical solution is to fall in love not with the instrument or tool that you use, but to fall in love with business incremental value that you bring. That is, I think it's always better for the company and better for your understanding of what you actually do. And I think that's the last most important thing that I wanted to say today. That's it. Thank you very much for your attention. I will be glad to answer all of your questions if you have them. And if you have them later, of course, you can get in touch with me by those contact details that you have here. And also there is a feedback form that we can provide you with the link to which we can provide you. That's it. So any questions?
I was just wondering, in terms of the business, yeah, you're saying the business assumption. Do you have an example that you can share of some time where you're maybe not so correct? Or the kind of assumptions you start with and how you might refine that? Just a moment.
I have some presentation. Okay, let me think about it when it may be just I'm trying to think in terms of this. For example, just simple example in the framework of this current discussion about credit card delta limit. If at some point we understand that the business model of credit cards is not good enough, and maybe we see that cash loans are better, maybe it's better to stop using those credit cards and to look beyond it and develop those cash loans. So we just create also some smart solutions for that another product. So just that might be an example of such thing. So we just don't concentrate on infinite usage of our solutions for things like credit cards. We can switch to other products like cash loans, or we can understand that developing our credit card portfolio is the wrong thing. Yes, so just in some longer horizons, it may cause some issues with bad debt, for example. Yes, which we couldn't see at our initial stages of business development. Yes, so just it may happen like that. I hope I made it quite clear. No?
Yeah, that makes sense. Yeah, thank you. Yeah.
Okay.
Yeah. Does anyone else have any questions? And if you want to put them in the chat, that's also fine.
Hi, I'm Gauri. I have a question on, the performance and the way the model is trained. Have you come across a, situation where it has taken a lot of time to train the model?
You mean do I understand correctly your question? So do you mean that do you want to understand whether it takes a lot of time to train model, or you just started by saying about testing, or what? Just could you repeat?
Testing, and then the training and testing part of it, because I don't have a production experience of training a model. I have done my MSc, where I had a hell lot of time in training the models. So that's why I wanted to understand like how it is in a production.
You mean how long does it take to train a model and then to test its performance?
Yes.
Or what? Oh, typically, let me just divide it into steps. First, when we train a model, it's pretty fast. Yes, so we do the simple procedures like, okay, we have training data set, we have testing data set, and so we use our testing data set to analyze whether on the data which is available for us, everything is fine, and it takes one day. I don't know, just maybe very fast. Yes, especially if you have good machines to train your model on, right? But then when it comes to deployment and you deploy your model, of course, you cannot predict right here and right now what will happen to the model, and you monitor its performance for some time. Yes, and it may last it depends on business task, of course. Yes, in terms of our example from today's session, you may see first results within a week. Yes, and you see that, for example, your predictions which you make go totally wrong. And if it happens, you can see it within a week, and you see, wow, we have got to stop all the process and understand what's going wrong right here and right now. So if to say shortly the answer to a question, typically training is quite fast, and then the understanding real life performance applied to real task, yes, it may take a week, or sometimes maybe several days. Sometimes it requires a month, depending on your business task, what you predict. Yeah, in my practice, for example, we typically, when we speak about credit card portfolio, debit card portfolio, or some other retail banking products, we think in terms of months. So, for example, in this task, we predicted actually 3 months delta debt. Yes, and of course, even within 1 or 2 days, it's impossible to see that something goes wrong, because clients may start using as much as we predicted. Even, for example, when there is a high level of seasonality in customers' behavior. For example, they don't behave actively at weekend. It's not about, of course, credit card users, but maybe about those who trade stocks on the stock exchange. Yes. So, and if you just start your model application on at weekend, you of course have to wait till Monday. Yes, and maybe some other days depending on the horizon that you used for prediction. So it depends. But typically testing model on a real data, I mean on a real life application, it takes longer than training. Training is very simple and it's very fast typically. Very simple. But of course, training the model, I mean fitting the model, but gathering and collecting and preparing data sometimes may be very hard task. Did I answer your question?
Yes, thank you very much. Thank you.
Oh, you're welcome. Okay.
I think in the meantime, I'm also just going to post in the chat. I've got a link to what has all of the Women Who Code London links, including if you want to join our Slack channel, or if you want to volunteer as well. I've been volunteering since August, and I'm now a machine learning lead. So if you do join Slack channel as well, you're very welcome to send me a message. Yeah, we've got we're organizing talks, and we'll probably do some machine learning competitions as well. So if you join or don't join, then you can keep an eye, I think, on our meetup page. Yeah, but yeah, so I've just posted that link in the chat if you want to take a look. Yeah, I definitely recommend joining the Slack channel.
And I said, by the way, before, if you have questions about machine learning applications or maybe about data engineering, because I have quite a lot experience in data engineering, of course, you can write me directly to the contact details that I provided. Yes, I'm always free to help out if you need some help or just, are interested in the subject. Yeah. So.
I just have another question. Sorry.
Oh, great.
What do you actually most enjoy? Data engineering part or a data scientist part? Because I come with a business intelligence background. So it's a bit of data engineering, but then data science is what kind of like, a very fancy job is what for me. So how do you actually like, see that as?
Okay, thank you for this question. What I want to say that I consider data science, data engineering, Python coding, R coding, SQL coding, and other things just like tools, honestly speaking. Just tools. And the part that I enjoy most of all is just getting final business results. As I said today, it's better to fall in love with incremental business value that we bring, not with the specific tools. And honestly speaking, sometimes you try to build a smart model, but then you understand that, okay, simple business rules maybe even work better than a smart machine learning model. Yeah. So I think that it's always good to fall in love with the business value. And so I enjoy most of all the moment when I see that what I've done actually brings extra profits, makes our clients happier, and things like that, not specific tools. Of course, I just consider those tools as tools. So, okay, I have the goal to bring value. And so which tools do I need to bring value? Okay, I've got to build a data mart. Then I build a data mart. Okay, I need a machine learning model. Then I fit a machine learning model and apply it to our clients. Yes. So the most, I think, enjoyable part is when you see real business results and you understand clearly how much value you bring. I think that's the best part, and that's the best part of my work actually. So I never fall in love with specific tools. So I've used in my career a lot of different tools, but now I just live in the mindset of bringing value. And so when I see that, okay, smart algorithms can bring value, then I use smart algorithms. When I see that just simple business decision making may bring even more value, then okay, let's use simple decision making because it can bring more value. So for me, my goal is to bring value and to see the results of my job. And that's it. So that's the most enjoyable part.
Thank you.
No, you're welcome. But anyway, of course, some tools, they just nice to use, nice to understand. You feel that, okay, I can write all those tons of code. Yeah, but finally, anyway, it's very important to see the goal. Yes, the goal is the extra business or the company where you work, or business or customer satisfaction. By the way, I have a lot of experience in working in CX departments as well. So not only base management, but CX, and there we created multiple solutions for customer experience. And so it's also possible to see some incremental value in terms of customer experience or feedback from our clients. Yes, but anyway, it's the final result which is the most enjoyable part. Okay, so if we have some extra questions I can answer, or we can finish because it's, I guess, 9 o'clock or 8 o'clock in London.
8 o'clock in London, yeah.
Yes, it's 8 o'clock. Actually, in Cyprus, it's 10 o'clock. It's 10 p.m., not 9. Yeah, but there is some time difference.
Yeah, well, thank you very much for the talk.
Thank you. Thank you for your attention. I hope you enjoyed this talk. If you have further questions, I will be very glad to answer them. Just you can write me a direct message or to fill the feedback form, which Irina, I guess, will send you. That's it. Thank you very much for your attention. I was, again, very glad to make this presentation for this wonderful society. Yes, thank you. Thanks a lot. Have a nice evening. And if you want some more speech, I can speak about some other things like data engineering, but maybe later. Thank you very much.
Yeah, thank you, everyone. Have a nice evening.
Have a nice evening. Goodbye.
Bye.